Hello everyone, welcome back to my general chemistry mini lecture. Today our topic will be limiting reactant and theoretic yield and percent yield. So first, let's talk about what is limiting reactant or limiting reagent. In a complete reaction, the totally consumed reactant is called a limiting reactant. And the other excess reactant is not totally consumed. So if a question tells you two amount of the two reactant, and you need to figure out which one is limiting and which one is excess. For example, this is a question. Which reactant is limiting? If 12.5 grams of hydrogen react with 26.3 grams of oxygen, according to this following balanced equation, how much excess reagent will remain? To solve this kind of limiting reagent problem, actually it's another type of mole calculation. So we can use two different ways to solve that. If you already watched my another video about stoichiometry calculation, yeah, we still have two different ways to solve. So here, for this question, I will show you the way using the mole ratio as conversion factor. So first, we need to calculate the molar mass of the hydrogen and oxygen. Hydrogen 2 times 1.01, that's the molar mass of one hydrogen. So that's 2.02 is the molar mass of this hydrogen molecule. For the oxygen molecule, 2 times molar mass of one oxygen, 16, that's 32 grams per mole. And then we can calculate the amount, the mass of oxygen needed for 12.5 grams of hydrogen. So we pretend we don't know how many grams of oxygen, but we will calculate how many grams oxygen need for 12.5 grams hydrogen. So we use mass over molar mass of the hydrogen, and then convert the moles of hydrogen to moles of oxygen, and then multiply with the molar mass of the oxygen. We can calculate 99.0 grams oxygen is required for 12.5 grams of hydrogen molecule in this reaction. Now we compare this needed oxygen with the actual oxygen. Seems like we do not have enough oxygen. So we need 99 grams, but we only have 26.3 grams. So we can make the conclusion, since there's only 26.3 grams of oxygen, that's not enough. So oxygen is a limiting reagent. That means oxygen is not enough. So hydrogen is excess. So when we do the real calculation, we need to use the limiting reagent to do the calculation. Okay, and the first step just figured out which one is limiting reagent. Then we can calculate how many grams of hydrogen needed for this 26.3 grams of oxygen. So use mass of oxygen divided by the molar mass of oxygen, and then convert the moles of oxygen to moles of hydrogen. Yeah, that's mole ratio. You see the mole ratio is coefficient ratio of that 2 to 1. Okay, so and then when we get the mole of hydrogen, we can multiply with the molar mass of hydrogen. We can find the mass of hydrogen needed for 26.3 grams of oxygen. Apparently, we only need 3.32 grams of hydrogen. That is way less than 12.5 grams of hydrogen. That confirms that hydrogen is excess, and that we can calculate how much of hydrogen will be left over. So the original mass is 12.5 grams hydrogen. We used 3.32 grams of hydrogen after the reaction complete. So the difference is 9.2 grams hydrogen will be remained. So this is the first example, and we can use this mole ratio to solve this kind of limiting reagent. Now the other example here is a very similar question, And then in this question, I will use the proportion way to solve this question. And the question is, which reactant is limiting if 3.65 grams of aluminum react with 31.7 grams of nitric acid, according to this following equation? How much excess reagent will remain? You see, it's a very similar question. And then we will use a proportion. So first, we write down the given condition. 3.65 grams of aluminum, write this under aluminum, and 31.7 grams of nitric acid, but we write X here because we want to find actually how many grams of nitric acid we will need for 3.65 grams of aluminum. And then we can compare this actual needed amount, the mass, with the actual given mass. So then we can find which one is limiting. So now first we calculate how many grams of nitric acid need to react with 3.65 grams aluminum. So then we need a molar mass of this 2 aluminum, 2 times 26.98, that's 53.96 grams for 2 mole of this aluminum. And for this 6 nitric acid, 6 times 63.02, this is 63.02 is the molar mass of 1 nitric acid. And then that is 6 times of the molar mass of nitric acid. We get 378.1 grams. Then, and write this 2 number, the mass, over this 2 number. So 378.1 here. Then that's in proportion. And then solve the X. X will be cross multiplication of this 2 number divided by this number. So that will be 3.65 times 378.1 divided by 53.96. We can calculate 25.6 gram nitric acid needed for 3.65 grams of aluminum. Now compare with the given mass. And we need 25.6 grams, but we have a 31.7 grams. So nitric acid seems like that is more than enough. So the nitric acid is excess and aluminum is limiting. So we can say that aluminum is limiting, nitric acid is excess. So then next step, just subtract 25.6 grams, this nitric acid will react. So initially we'll have 31.7 grams. The difference is 6.1 grams. That is how much of this excess reagent remained. Okay, so now this is 2 examples, shows you 2 different ways to find the limiting reagent and find the remained excess reagent. Now let's talk about question about the yield, like a theoretic yield and percent yield. And for this kind of question, we also usually need to figure out the limiting reagent first, and then use the limiting reagent to calculate the theoretic yield, and then calculate percent yield. The theoretic yield means if the reaction run 100% conversion and no any product lost during the lab, then that's the maximum amount of possible yield we can obtain. And in a real world, that's not possible. That's why we will have actual yield. The actual yield divided by theoretic yield, and the percentage is called a percent yield. So example shown here. 97.8 grams of carbon dioxide was produced from the reaction, from this reaction, and between 112 grams of this is called propane, that's a very common fuel, and 245 grams of oxygen. And then what is this percent yield of carbon dioxide? So see, this is actual yield of the carbon dioxide, one of the product, and you want to find percent yield. So first you need to find a limiting reactant, and then you need to find a theoretic yield, and then you can calculate a percent yield. This is a balanced equation, so we can use the mole fraction way. So we can do 2 stoichiometry. We can calculate how many grams of carbon dioxide can produced from this propane in theory. How many grams of propane? 112 grams divided by 44.10. That is molar mass of this propane. You can calculate based on the formula, okay? And then you convert the moles of the propane to carbon dioxide. That's the mole ratio, 3 to 1, okay, the coefficient ratio. And then convert the moles of carbon dioxide to mass of the carbon dioxide. Multiply with the molar mass of this carbon dioxide. That's also calculated based on the formula, 1 carbon, 2 oxygen in the formula. And then we can calculate 335 grams of carbon dioxide can be produced from the propane in theory, again, in theory, okay? And then we can calculate how many grams of carbon dioxide possibly can produce from the oxygen, 245 grams of oxygen. So another stoichiometry. 245 grams of oxygen divided by the molar mass of oxygen, and then convert the moles of oxygen to moles of carbon dioxide. Again, mole ratio is 3 to 5, 3 to 5. And then multiply with the molar mass of carbon dioxide. We can calculate 202 grams carbon dioxide can be potentially produced from the oxygen in theory, from 245 grams of oxygen in theory. Now, compare these two possible mass of the product, we need to pick up the less amount. And so this is actually real theoretic yield. So in theory, we can only produce 202 grams, and that is from the limiting reagent, that's oxygen. So we cannot make that much because this is the propane, the excess. Conclusion, limiting reagent is oxygen. Theoretic yield is 202 grams. And then we can calculate percent yield. Percent yield equals the actual yield over theoretic yield. That's 97.8. That's the given condition, 97.8 grams of carbon dioxide divided by theoretic yield. That's 202 grams carbon dioxide. And the percentage is 48.4%. That is a percent yield. Okay. Another example of this similar question is shown here. The reaction is decomposition of the potassium chlorate to potassium chloride and oxygen gas. So if 35.6 grams of oxygen was produced from 125 grams of potassium chlorate, according to the equation, what is the theoretic yield of oxygen and what's the percent yield? Now we can use the proportion way. We have 125 grams of the potassium chlorate, and we can say, I don't know how many grams of oxygen, but we'll put X here. X grams of oxygen could produce, and then we need to find the molar mass of the potassium chlorate is 122.6, and then multiply with the coefficient 2, that is 245.2 grams. That is the total mass of 2 moles of this potassium chlorate. Same thing, 3 moles of oxygen. Oxygen molar mass is 32 times 3, the coefficient, you get 96 grams of this 3 moles of oxygen. Move this number, the mass, down, and then they are in proportion. And then you can solve the X. That's cross multiplication divided by 245.2. That's 48.9 grams oxygen will be produced in theory. That's a theoretic yield. And then we can calculate the percent yield. That's again, actual yield, that's a given 35.6 grams over theoretic yield. The percentage is 72.8%. Okay, I will give you one more example, then that's all the report today. This example, it's another example. So that's need to calculate the percent yield. We have 3.45 grams of silver chloride was produced in this reaction. That's one of the product from 7.52 grams silver nitrate and 2.18 grams of calcium chloride. How much excess reagent remained? What is the theoretic yield of silver chloride and what is percent yield? This is a balanced equation here. Okay, so you have 2 silver nitrate react with 1 calcium chloride, will produce 1 calcium nitrate and 2 silver chloride. And that's coefficient ratio is also mole ratio. Okay, here I will show you, again, use the proportion way. So we have given 7.52 grams of the silver nitrate, and we can calculate how many grams of the calcium chloride will need to react with 7.52 grams of silver nitrate. So again, we calculate the mass of the 2 mole of silver nitrate, 2 times the molar mass of silver nitrate, and 339.8 grams. And then calcium chloride, that is a molar mass of 1 mole of calcium chloride. You can calculate 111 grams per mole. And then move this mass over this given and over this x, that's 111 in proportion. And then we can solve the x. X equals 7.52 times the 111 divided by 339.8. That is 2.46 grams calcium chloride will be needed. Now compared with the given 2.18 grams. So apparently 2.46 grams calcium chloride is more than the actual given mass calcium chloride. So the calcium chloride actually is limiting. So we have to say the silver nitrate is excess and the calcium chloride is limiting. So we will use the mass of the calcium chloride, which is limiting, 2.18 grams, and set up the mass of the silver nitrate needed as x gram. Now we can solve the how many grams of silver nitrate, which is excess reagent, x equals 339.8 times 2.18 divided by 111. Based on this proportion, we can calculate 6.67 grams silver nitrate will be consumed, reacted. So what's left? So remained silver nitrate, the excess reagent will be original amount 7.52 minus 6.67, that's reacted. So left over is 0.85 grams silver nitrate. That solved the first question. Then what will be theoretic yield? That's another question. We can say y grams, so that's unknown, y grams of the silver chloride will be produced. And then we know the mass of the 2 mole of silver chloride is 286.6. So move that number here, and then that's another proportion. And then we can solve this y. Y will be the cross multiplication of this 2 number, 286.6 times 2.18 over divided by 111. We got 5.63 grams of silver nitrate. That will be obtained. Yeah, that's a typo. Okay, this should be say produced. Okay, and then theoretic yield of a silver chloride is 5.63 grams. And then what's the percent yield? The actual yield is the 3.46. That's given grams. So actual yield 3.46 gram over theoretic yield 5.63. The percentage is 61.5%. Okay, that's all I want to talk about this limiting, excess, reagent, and theoretical, and the percent yield. Okay, if you have any questions, please let me know. Okay, good luck.